Look at you, you poor thing. You're in need of a good dose of Viagra. Just like your creator. Hey, peeps. Welcome back. And here we are at part 1 of our 3 Degree of Freedom Motion Platform Simulator mid-frame build. Now, all jokes aside, we do need to get some measurements so then we can get our placement correct for our mid-frame uni joint, which will connect to our top frame, which allows our top frame to pitch and roll. So let's do that. Okay, guys, before we go too crazy, your 100 millimeter by 50 millimeter by 3 millimeter box that I advised you to purchase 2 meters in length of, that is now becoming your mid-frame spine. Rightio, and you need to cut your 2 meter length at exactly 1840 millimeters. So let's talk about an important part of our build, and that is going to be our finishing height from the top of our mid-frame to the bottom of our top frame. The way our mid-frame and our top frame are connected is via a uni joint. The uni joint allows our top frame to roll and pitch. The important measurement in this design is the finishing height. So from the top of our mid-frame to the bottom of our top frame, so the distance between here and here is 275 millimeters. That's how long you need to have your uni joint attached to your mid-frame. Now, I'm going to assume that you guys have all sourced a rear wheel vehicle tail shaft. Now, your uni joint is not going to be as large as this uni joint. This uni joint has come out of a Cat 3 tractor. Your uni joint is going to be a lot more compact than this. So to get the height that you need, you're going to have to measure a section of your tail shaft that connects into your uni joint, and you'll have to cut your tail shaft. But you need to take into account that you're going to be using your leftover 160 millimeter length of your 50 by 100 box to weld and center on top of your uni joint. So your finishing height from the top of your mid frame to the bottom of your top frame, which is 275 millimeters, needs to take into account you will have a 50 millimeter section of box welded on top of your uni joint. Now, with your vehicle tail shaft, we've talked about our finishing height, right? You will need to basically cut your tail shaft section before it joins to your uni joint at the appropriate length to get your finishing height. You'll have to work that out off the measurements that we've already been through with our finishing height on our uni joint to mid-frame. Now, let's just take a step back in cutting your tail shaft, because you need to get that tail shaft where you cut it needs to be straight. One of the best methods for doing that is to get some masking tape and wrap it around the tail shaft where you need to cut it. So you've measured it, you know where you've got to cut it, you've marked the tail shaft, then you will run some masking tape around that mark. You bring the tape around onto itself, and that becomes your template for where you're going to cut and use your angle grinder to cut through your tail shaft. And that'll give you a really nice cut. So then when you put your tail shaft on the mid frame, it's not skewy, it's straight. So what you need to do is your normal due diligence on your tail shaft, prepping it before you weld it. Once you've cut it, put a good bevel in the tail shaft. Put a good bevel in it like we've done with all of our other welding pieces to create a gap so then you can get good fill weld. So with that in mind, and with your correct height established, let's talk about how we connect our box and get it centered on our uni joint. And then let's talk about how we connect our uni joint with our box attached and get it centered to the longitude and the latitude axis on our mid-frame. So before we attach our uni joint to our 160 millimeter length of 100 by 50 by 3 mil box, on the opposite side of where we're going to weld our uni joint on, we need to prep our 160 millimeter piece of box to drill some holes to take some bolts, because what's going to happen here is our top frame has a plate welded to it, and that plate will attach to this box via bolts. That way, when we need to take our sim rig apart, we can take it apart without any problems. So we don't weld our mid-frame to our top frame, it's attached by bolts. This is what you're going to do on your 160 millimeter piece of 100 by 50 box. Here's your 160 millimeter length of box. You're going to measure in from one edge, 10 millimeters, make a mark, put your square on, draw a line. The other side, you're going to do exactly the same. Measure 10 millimeters, make a mark, put your square on, draw a line. On the long side, from these edges, get your ruler flush on the edges, measure in 20 millimeters, make a mark, come along, measure 20 millimeters in, make a mark, put your ruler on, draw a line. Exactly the same for the opposing side. Then what you're going to do is at your intersecting lines, as always, here, 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 and here, you're going to punch. And you're going to drill a hole with an 8 millimeter drill bit. We will be using M8 bolts. You need to get M8 bolts that are 30 millimeters in length, and you need to make sure that you get the matching nut for whatever the thread pitch is on that M8 bolt that you've chosen. Also get a spring washer, and obviously you're going to need 4 of them. These measurements allow us enough space to hold our bolt head when we do up our nuts. But we need to be in enough so then our bolt heads, which will be on the inside of our box here, clear our edge. Okay, so it's in enough to have plenty of meat in the box, but not so far that we can't hold our bolt head while we do our nuts up. So it's important to make sure you follow those measurements. So we need to prep our 160 millimeter long 100 by 50 mil box. We need to get the center of it, because you're going to need to get your uni joint centered on this and welded on this before you connect your uni joint to your mid frame. So it's just a matter of some simple mathematics and measurements, guys. Your piece of box is 160 long, so half of that is 80 millimeters. Okay, so put a ruler on your 160 millimeters, find 80, make a mark, put your square, draw a line. Okay, then measure. You need to measure half of your 100. So find 50, make a mark, put your ruler nice and flush on the edge of your box, find 50 millimeters, make a mark, put your ruler on those 2 marks, draw a line. There's your center of your box. So the difficulty for me trying to help you guys align your uni joint centered on your piece of box is that I have no idea what size your uni joint flange is going to be, because I don't know what the uni joint is that you're going to end up obtaining. So you're going to have to work that out. You're going to have to work out how to center your uni joint and mark it. All right. So then you can clean up your box and you'll clean up your uni joint flange. You'll put it back on, then you'll tack it so it doesn't move, and then you'll weld it. So I can't really help you to work that out. You're going to have to work it out. I was able to find for my uni joint one of my cut-off discs, and very handily these cut-off discs actually had spot welds diagonally opposite from each other. I was able to use those spot welds to line up on the lines that I'd drawn to center my box. And then I just by eye got it in the center. I was able to mark it, clean it up, and I knew the uni joint was going to be in center. So you need to get it as close as you can, weld it onto your box. Then we can talk about how we are going to connect our uni joint with our box now on our uni joint to our mid frame. You're going to take your tape measure and you're going to place it right at the back of your mid frame. And you're going to measure out 395 millimeters, and you're going to mark your mid frame at the 395 millimeter point. You're going to take a ruler and you're going to find the halfway mark of your 100 millimeter box. Slide your ruler up a little bit and make another mark. Put your ruler on those 2 marks and draw a line so we've got a straight line on the center of our mid frame. So a very handy fact about our uni joints. they have bearings that are centered in our uni joint's housing. So we can use those bearings to help us line up and get centered our uni joint. So what you'll need to do is on one side of your uni joint where your bearing caps have been pressed into the housing, you need to find the halfway mark of that bearing cap and mark it. Then mark above it and below it on the housing. You're going to do exactly the same on the opposing uni joint bearing cap. So I've given you your measurement from the back of your mid frame to where your uni joint will be centered at 395 millimeters. So before we try and do all of this business, okay, make sure your mid frame is all cleaned. Make sure you've taken all the paint off and the area where your uni joint is basically going to sit. Now you won't have it exactly right, but if you measure this measurement on your mid frame first, 395 millimeters, you'll know that, and you can just sit your uni joint on there temporarily, you'll see basically how much material you need to remove to have a nice clean surface to weld this. The great thing about having your box already welded onto your uni joint means that you are going to be able to use your box to aid you in getting your uni joint square with your mid frame. This is very important, guys. We cannot afford to put our uni joint on, right, skewed in any direction. It has to be straight with our mid frame. If we don't get this right, and this is critical, if we don't get this right, when we put our top frame on, our top frame is going to be skewed. That's going to mean that one of our motors at the front of our mid frame is always going to have to work harder than our other motor because the balance will not be right. So we have to get this right. We have to get our uni joint centered on our mid frame, both on the longitude and the latitude. And we can use that box to aid us. With my box, because of the nature of my uni joint, my box pretty much sits on my mid frame with my uni joint housing almost horizontal. Now, if it wasn't, I could chock this with something underneath it, right? So you may have to do the same with your piece of box. You may need to chock your box to get it straight. But what you're wanting to do is you're wanting to check, right, how your box is sitting on your mid-frame box. And you want the edges of your box on your uni joint parallel with your mid-frame. If you've got that, that is going to make your job a lot easier to center this because you can use that as a guide. Then the marks you've made on your uni joint caps, and then the distance here from the rear of our mid-frame to where the center of our uni joint has to be. You can put a square on your mid-frame like this, bring it along to the mark on your mid-frame, and then line it up with the marks where you've centered them on your bearing caps. Then you know that the uni joint is centered with that mark. This mark's important because this where I've placed this uni joint in this design means that our top frame has excellent balance and your motors won't have to work too hard. You're going to do exactly the same at the back here where you've centered your mid frame along the latitude here, right? You're going to put your square on that mark and you're going to line it up with your bearing cap, center of your bearing caps. You're going to use those two methods to get that centered along with looking at your box and making sure it's square. Then what you can do is you will then tack your uni joint into place. Let's have a chat about how we're going to weld our uni joint to our mid frame. Now, I'm assuming you guys will end up with a rear wheel drive vehicle tail shaft. You won't have surplus Cat 3 tractor PTO shaft uni joint lying around. So I had a bit of a hell of a time connecting this uni joint to my mid frame because this uni joint came from a damaged Cat 3 tractor PTO shaft. And when the PTO shaft actually failed, it actually damaged where it connected into this uni joint. It actually damaged, it fatigued the metal on the uni joint. The metal was split and it was pretty wild at this section here. So I actually had to fix it all up and re-weld the actual housing of the uni joint. I ended up having to use my stick welder on the highest setting with 3.2 millimeter electrodes because I had to do a lot of filling to repair this. But hey, it was free, and so it was worth my time just to repair that. Got it sorted out, and then I was able to basically weld it onto the mid-frame. So once you've placed it on the marks that we've talked about and got everything centered, okay, what you will do is you will put 4 tacks around your uni joint right into where you've beveled it, okay? 4 good tacks, do them opposite each other. This needs to be a very strong weld. Because of the nature of our mid-frame, we don't have a lot of space to run any bracing. You won't need to do that. If you follow my directions now on how to weld your uni joint on your mid-frame, we won't need to worry about any bracing. So what you need to do is your normal due diligence on your tail shaft, prepping it before you weld it. Make sure you put a very good bevel around your tail shaft. You're going to run your first bead into that bevel between where your tail shaft is and where your mid-frame is. You'll run a bead right around in that bevel. Then you're going to run another bead, and you're going to spread that bead a little bit more so that it's contacting the tail shaft and the mid-frame. That's weld number 2. Then you're going to weld on the top side of that weld, mainly into your tail shaft. And you'll run a bead right around. You'll weave it more onto your tail shaft. Then your 4th and final weld, you'll then weld below that, and you'll weld from the bottom of that weld into your mid-frame, okay? And that will give you ample strength to keep this on without needing to brace it. Remember, your 50 by 100 box here is 3 millimeters thick. You can put a lot of heat into that before you'll blow a hole in it. And so you'll get good penetration, and that will be more than strong enough for the life of your motion sim. So they're the tips I can give you. Sorry, I can't show you how to do it. Obviously, mine's already on. If you follow the directions I've just given you there, making sure all of your pieces are very clean, and you do what I've just described to you in the welding process, you'll have a very strong connection with your uni joint, and you won't have any problems for the life of your sim. Good luck with that, and I'm rooting for you. Wow. Well, that was a pretty full-on part of the build, guys. There is no doubts that that is probably the most complex part of the build, but it's also the most critical part of the build. This is a part of the build that you cannot afford to mess up. You cannot afford to cock this up. There's no other way to say it. So the way to avoid that is to double check, triple check all your measurements and take your time placing your uni joint on your mid-frame. There is no reason whatsoever that if you make a mistake, you can't cut your weld and start again. The way to do this the most successfully is to get everything set up just with tacking. Also very important to double check all of your measurements before you start laying down your main beads. Because then if you have made a mistake and you've already started doing your full welds, it is much harder to cut your piece back off. This is why when we fit this sort of stuff and build things, we always just tack stuff together and then we double, triple check our measurements. You guys need to do the same. So once that uni joint is on the mid-frame, lined up with all the marks that we've just gone through in the video, get it tacked and then get your tape measure and your square and double check everything again before you put your permanent welds in. It's going to take a little bit of time to do that, but it's well worth it if there is a mistake, because it's much easier for you guys to undo what's been done, set it up again and have another crack. It's important to get this right. There's no rush to do this, guys. I know that you're absolutely pumped and excited to have this thing actually working in games, and that's great. That's going to happen. If you're loading your motors because the balance is not right on your motion sim, you will start having problems straight away with your IBT2s, because your motors will have to be working hard if the balance is out. If things are not correct in the build, your motors are the ones that are going to be the element that is suffering. They in turn will then start drawing more amps because they're having to work harder than they should because the balance is not right. That will directly relate back to your IBT2 motor controllers, your H bridges, and you'll start burning them out. And you will long term shorten the life of your wiper motors. I cannot hammer this home more. Take your time with this part of the build. This is the hardest part of the build, and once you're through this, things are a lot easier and a little bit more cruisier on the rest of the build. You're doing really well, guys. The comments are just a few keystrokes away. Where you're having problems, please leave us a comment and I will do the best I can to help you guys out with questions that you may have or issues that you're having or parts of the build that you're struggling with. I'm sure we can work a way around you being able to get over the line. so to speak. Really appreciate everyone who's subscribed. You guys are a bunch of legends. I'm looking forward to part 2 of the mid-frame build. Certainly looking forward to things being a little bit easier after this part of our build. So guys, until our next session, stay safe out there, stay healthy, and we'll see you next week.